Welcome to today's session. Today we're going to be going through Assisted Lab number 3, where we're going to be intercepting and interpreting network packet capturing tools. We're going to be using Wireshark, we're using TCP dump, and we're going to capture different packets over the network, and we're going to interpret those packets, we're going to interpret our captures, sort them, filter them, and look through the results. So we're going to use this, we're going to answer some questions, and I'm going to teach you how to use this information to help pass your exam. And how to interpret this information if you're looking at Wireshark yourself. So if you have Wireshark, you have your own version of Kali Linux, that's what we're going to be using first. I invite you to go ahead and follow along. If you have access to the CompTIA Learn Lab environment for Security Plus, you can go ahead and pull up Lab 3. If you have any questions, let me know throughout the activity, or email info@cyberkrafttraining.com. Anyway, let's go ahead and get started. Scenario says we're going to be using Wireshark, a TCP dump. So let's go ahead and start working on this. I've already logged in my Kali machine here, and I've opened up the Wireshark application. Now we want to ensure that we're using the correct filter. Okay, so we want to go to capture and then option, and we're going to see that our interface is F0, and that's what we want to use for this scenario. So we have F0 selected, and you can change these options in this options menu. So if you have different interfacing, you can select which interface you want to use. And that interface is in promiscuous mode, which means that it's enabled to sniff packets from the air. So we can allow that on that F0. So we're going to go ahead and hit start. Now it's asking us to select a filter here, so we can also set up a filter if we go to capture and then options. There's two different types of filters. There's display filters and there's capture filters. Capture filters are going to they're going to restrict what is actually captured, what type of packets we're sniffing, and then display filters are applied to packets that we've already captured or files that we're analyzing. You can have whole packet dumps that you can analyze, and you can sort your view of those packets through view filters, essentially. Okay, so those are called display filters, but we're going to put a capture filter on here of IP, and what that's going to do is that's going to restrict us to only IPv4 addresses. It's going to exclude IPv6 address. We're going to go ahead and click start, and it's start whenever you see this red square come up. That's going to give you the button to stop the packet capture. Okay. Now let's go ahead and open a web browser so we actually generate some packets, and let me have Wireshark up at the same time so we can see what's going on. All right, I'm going to open Wireshark, or open Firefox, and you can see how this is generating packets already. Now I'm going to go ahead and connect to our managed server 1 by doing the IP address 10.1.0.2, and that's going to connect to the 515 support user portal, one of the best, most well-designed websites in the history of mankind. But anyway, this is our tech support website that you use often in this lab environment, and you can see that we have some destination IPs here, source IPs. We have some information where we are connecting to that website. Okay, so you can see that right here. Our source IP is 10.1.0.192, and we're establishing a TCP connection. So we can see that TCP process right here. And we've sent a synchronization packet, then 10.1.0.2 sent back a SYN-ACK packet. And then we've established our connection here with acknowledge packet, and then we have an HTTP request. So we've established a TCP IP connection, or a TCP connection. You see that right there, that whole sequence, a SYN, a SYN-ACK, and an ACK. So if you ever wondered how that's actually used, those are the packets that are sent right there, and we can examine those packets there. These are the packets themselves. Okay, so that can be pretty useful. So if you've ever wondered what this process looks like, what does a TCP handshake look like, there's one in the wild. So now you know what they have. Okay, so we've established that. We've captured packets. Now we can stop at a time. This is a live capture, so it's constantly capturing packets here. But we can go ahead and stop that, and then we can analyze the results we have. Now, as you see here, this is color-coded. You have color-coded bars for different types of connections here. Okay. So we have different protocols, and the protocols usually denote the type of packet. So ICMP is listed in black, DNS is light blue. We have TCP, HTTP, those are in like a light, like a pea green. So all of these different types of protocol. And we have some different packets here too. These are from, yeah, so each of these usually gets a different color code. Okay. Now we can use a display filter now, so we can type DNS in here. Okay. And then we'd only get our DNS packets here. Let's see. Now, looking at our Wireshark capture, we're going to go over each of these components. Okay. So we have different panes here. First is going to be showing all of our results. Next, we're going to see some more detailed information. And the third pane is going to be information on the packet itself. Okay. And if you click down here, you can see information about each of these selections that we're doing. So let's go ahead and take off this display filter. And I'm going to go ahead and bring this up to, let's go ahead and apply that. Get back our TCP and HTTP packets there. Okay. So here we have a TCP packet. Let's go back to that SYN-ACK and ACK packet. So here we go. We have different, like here's the address, okay, the header, essentially. We have different portions of the packet. You can see how as I'm moving along here, you got the source port, destination port, sequence number. All of this is different portions of the packet are transmitting different pieces of information. So it's useful to understand what you're looking at here. And we can see our different flags. We have flags in this packet. We have and the flags in their corresponding area. So these flags are going to be reserve bit, don't fragment, more fragments, type of protocol, header, source, destination. So this is the information you'll get from the second pane here. It's going to give you the size of the packet, information like that. Let's see. Okay. Now right here we have the frame. I'm just going to explain the information that CompTIA wants you to focus on. So this is basically your general information about the packet. Number of bytes, size of the packet, what interface it was distributed on. We're using just F0, so everything's going to be on F0. The bytes of the packet. Then we have Ethernet 2, okay, from source Microsoft to a, so this is a, let's see, source MAC address, destination address. Now this is, it says Microsoft because this is a virtual machine. Even though this is a Kali Linux machine, it's going to take on the attributes of the host machine. So this Kali Linux machine is being hosted by a Windows server, which has created that virtual instance. So that's why this source is coming off as a Windows MAC address. And that's noted here because it's using a Microsoft virtual adapter. It shows us in the next little pane here that this is an IPv4 address. Now that's, of course, it's going to be IPv4 because we put that capture filter on there to only capture IPv4. IPv4 packets. Now, sometimes there's a locator on this, but there's not going to be one here because this is a private IP address. So if we have a private IP address, that's created using network address translation, we're not going to have that geolocation. If this was a public address, we would. Okay, then we have, let's see, the type of protocol. This is the TCP protocol, or TCP protocol for that type. We got information about the source port, destination port, source port 47358, destination port 80. And different information there. The type of packet this is. If we had like DNS, we'd see our port as 53. See, destination port 53. Here we're doing destination port 80 because we're ultimately retrieving a website. So we're using HTTP. Okay. So this is kind of how you can use this information. And then if you want, you can examine the actual packets itself. Now, Wireshark can help you search for things like passwords and transmitting passwords, certain pieces of information. You can put different filters on here to search for that within these packets as well. So if you're looking to capture plain text passwords set over the air, you can use Wireshark for that. All right. All right, so let's answer some of these questions here. I hope that was helpful. I think it is helpful to know what these packets are about and to learn the specifics of the packets. So let's answer these questions. The Wireshark interface, what is the name of the layer where the MAC addresses are found? Layer where the MAC addresses are found is going to be here. So it's going to be Ethernet 2. Okay, in the Wireshark interface, what is the name of the layer where the IP addresses are found? Okay, so the IP addresses are going to be an Internet Protocol version 4. And then the last one here, in the Wireshark interface, what's the name of the layer where the source and destination port numbers are found? And we can find that here, source port, destination port, so that's going to be transmission control protocol. Great. Okay, so we did all that. Again, if you want to click it all at once, click all these checkboxes. After you're done with the whole section, sometimes that's helpful. Just hit OK when it asks you to do so. All right, so now we're going to be using TCP dump. So we went over Wireshark a little bit. Now, of course, there's a lot more you can do with Wireshark, but as a good introduction, let's go ahead and head over to our managed server 1. We're going to sign in using our default credentials here. That password $$W0RD. If you're typing it in manually, it's a 0. And we're going to pull up Server Manager. And we're going to go ahead and select Tools, IIS, Internet Information Services Manager. And from our IIS, we're going to go ahead and select our site nodes here. Okay, and we're going to go to default website node from our MS1. So we go to default website node. Let's go ahead and find that. Default website. We're going to click on authentication. Make sure you click not just here, but you want to click here. You want to expand this caret down to default websites, and then you want to double click on authentication. Anonymous authentication, we want to disable that. And then basic authentication, we want to enable that. In a real server, you wouldn't want to do this, but we're doing this for packet sniffing purposes. Okay, so basically we're disabling SSL or transfer layer security for this session. Let's go back to our PT1. Okay, and then we're going to go ahead and we're going to log in We're already logged in. Let's go ahead and open terminal here. And then we're going to run a command. Now, I think it's important to learn how to do these command prompts, these commands, not command prompts, but to type in these commands yourself. So we're going to type these in. Now, with the Linux machines, you have to. With the Windows machines, you're going to be given the opportunity to hit a green button to type. But I highly recommend that you always type these out yourself. It's going to help you learn the commands. If you make any errors, it's okay. Remember, in Linux, you can always hit the up and down arrows to get your previous inputted command. Okay, so we're going to go ahead and type in some TCP dump commands here. So TCP dump, very verbose, DST 10.1.0.2 and port www-w www.pcap. So basically we're listening now using our Ethernet adapter Ethernet 0, and then we're going to be listening for different packets. All right, now let's go ahead to the managed server 1, and let's go ahead and log in here. Let's see. Oh yeah, we have to refresh the page because we changed those settings. Now we're able to log in. Our username is going to be 515support/administrator. And then our password is going to be password. Okay. Now we should have logged in right there. We're going to go back to TCP dump. It says it's got 13, which means it's capturing some packets. So we have 13 packets there. We're going to stop the capture. Okay, we're going to go back to Wireshark, and we're going to open the packets that we captured from TCP dump so we can analyze them. So let's go ahead and find those packets. We got to find them in root. They should be right here. There they are, www.pcap. Go ahead and click open. We don't want to save the packets that we already had. And here we go. We have our packets that we captured. Now let's take a look. Try and figure out what these are just without me telling you here. So we have a SYN, an ACK. Okay, we're getting an HTTP address here. Now, we're going to be looking here for a password, essentially, okay? And that's really our goal. And we're going to be finding that with the get HTTP. So let's take a look at our get HTTP and see if we could see anything that could help us determine the credential. Now remember, our password is that PASSWORD. Okay? So where can we find that? Now there's some ways you can do this. You can search for some different ways in your displays filter. You can there's all sorts of display filters that we're not really going to get into today, but there's tons of options here. And if you click this down caret, you're going to get the display filters that you've had before. So we can just filter out to our get. Let's see, we can also do that by just sorting from our protocol or our different types here. So we have our HTTP. You can do this by info too. So we get all of our gets in a row. The filter for that, you would do just HTTP. So our HTTP get. And we're going to be filtering these by these types of packets. So let's go ahead and open up one of these packets, these gets, and see if we can see anything in here that shows what type of the authentication information. Okay. Now we're going to use that by finding the hypertext transfer protocol. We're going to expand this section here. And we're going to have authentication information or authorization information in here. And here we see our credentials right there, 515 support/administrator/password. So you can find that authentication information, and that's going to be a password. Again, this is over port 80. So if we look at our port, this is HTTP. This is unsecure, not HTTPS, which would be 443. So because of that, we're able to capture those packets, capture that authentication information, and find that password in plain text. So we're going to see that authentication information set as the username and then the password. And we see that right there. So that allowed us to capture that password. Okay. All right, so let's go ahead and intercept some SSH traffic now. Let's go back to our Kali machine. We're on Kali. Let's type in another TCP dump command. Now we're capturing 10.1.0.10. We're specifying the port as SSH. And then we're going to be committing this to a file called ssh.pcap. So now we're listening here. We're open up a second terminal. We're going to go ahead and type SSH root at 10.1.0.10. So we're establishing a TCP or an SSH connection to 10.1.0.10. Now we're gonna hit yes to allow us to continue connecting there, and we're gonna go ahead and hit. We're gonna put our credentials in here. If you're ever unsure what the credentials are within the Slab environment, it's always going to be that PA $$ W0RD. Now, when you type the password in, it's not going to list anything. In Linux, when you're typing the password, it's not going to show up. Just rest assured that it actually has connected, okay? Or you are actually typing something in. It's just not going to display on the terminal. So we went ahead and logged in through SSH. We're doing the hostname command, and we're doing who am I. That shows us that we are on LX1, which is one of our other servers here, one of our other virtual machines, and that we're logged in as the root account. Okay? So we're going to go ahead and then exit out of that, and we're going to close that connection. Now we're going to go back to our TCP dump. Control C. We stopped. And now we're going to go back to Wireshark. We're going to open our new capture, ssh.pcap. Go ahead and open that up. And here we go again. We see our connections to the SSH server. Now you see that we have this lovely shade of lavender for our SSH connections. And that comprises most of these. And then we have some TCP connections as well. So we have a SYN, ACK, and we have SSH v2. We know our destination port is 22. Of course, this is a SSH. Okay. So that's important to note. Now, if you're wondering why we can't find that, it's because we've been using SSH here and we're not able to find that information. So the answer to this question down here is going to be no. Okay. So what we looked there, we looked at HTTP and SSH traffic doing our comprehensive questions. And would an eavesdropper be able to intercept and read the contents of a web page in the MS1 virtual machine if the web server required HTTPS? So no. That's because we're using an encrypted connection there. Okay, so that finishes up our connection here, our questions. We've answered everything correct, so go ahead and submit that lab. And I hope this was helpful, give you an idea how to use Wireshark. Remember, when you're sniffing unencrypted traffic, you could find credentials like we did with our finding that password connection, the 515 support administrator, and then the password. Or if you're sniffing an encrypted connection like we did through SSH, that's not possible. You're not able to find that connection or find that set of credentials because the session itself is encrypted. You'd have to do some sort of man-in-the-middle attack to be able to sniff that information. So great job following along. Let me know if you have any questions. Again, info@cyberkrafttraining.com. And thanks so much. Have a wonderful day.